Hey guys, right here, welcome to the channel. So today we are reviewing this RUIXU Server Rack battery cabinet, as well as these RUIXU Server Rack batteries. We're going to be building this whole system. We're going to put the batteries in the cabinet and connect it up, and we're going to hook this into my inverter that's going to be running my house, and we're going to see how we like it. So if you want to have some fun, come along. So first impressions looking at this system, it is built very solid, 29.5. If you take the wheels off, it's roughly just over 39 inches tall and 2 feet wide. So when I was unboxing this last night, my neighbor was walking by, he thought I was unboxing a safe. About the same thickness as my cheap RV frame. Look at these welds. That is just solid. This door, you can slide these and this door totally pops off. Here's our bus bar. Comes with some keys. The back door opens up. The front door opens up and has these keys. These shelves are movable if you have some different size batteries. This is where the wheels come off. This door opens up, and so you can run your wires underneath to your inverter if you would like. These are like flexible plastic tabs, so you can move them out of the way, connect onto the bus bar, or you can move them back if you change your mind. If you want to ground this cabinet, there's grounding screws. Even on the door, have a look at these hinges. 3 hinges, they're just solid. Looks like there's this, I'm not sure what this is, but it's like a foam insulation. Not really needed because this isn't watertight because there's these vents, but it makes it so it doesn't slam and it pulls it tight. So these 4 access holes, you can pop this ring out and use this as a grommet if you want to feed wires out of here. Not sure why you'd want to take the side off, but you can. So this specific cabinet holds 6 batteries, but they do sell another cabinet that can hold 10 batteries. So one thing nice about these smaller profile batteries is they have a smaller profile cabinet. So this cabinet, I can take the wheels off, and if I take the wheels off, this can sit on the ground. From the ground to the top, it's like 39 inches. So theoretically, I could get 2 of these, put them side by side, then put a workbench on top of it. So these batteries just be hiding underneath my workbench. But that's not something I can do with the EG4 cabinet, because the EG4 cabinet is about this much taller. So this cabinet is about, I think it's a few inches longer than the EG4 cabinet though. I think I might just stick this right here in the corner, but I think I can run my inverter cables right through this top hole. Or if I wanted to run them through the side, I could always drill a hole here and use conduit. So I think these are called Amphenol connectors. Really like them. It's super easy. Clip on there. Connect that to that. What'd you say?
Nothing. Looks cool. Looks really nice.
What'd you say before that?
This is intense.
Like camping?
Oh, I don't know.
Oh, okay.
I can't remember.
Okay, so I'm going to have closed loop communication with this setup. So basically I'm going to have all these dip switches down, and this is going to be my master battery. So on my master battery, I'm just going to move dip switch 6 to the up position. So these batteries have a program supposedly where you can monitor the state of each battery. So I'm going to download that program. I use this communication cable here. I'll plug this into the battery, and I'll plug this side into my computer with a USB. Now, this is a pretty common cable for monitoring batteries. I think this came with a battery, I'm not sure. If not, they sell this cable for pretty cheap from Current Connected or Signature Solar. But let's download the program and see what kind of information we can see. Okay, I had to email RUIXU support in order to get this program. It's called RUIXU software. They should really have this available for download on the website. So I'll just extract all. Okay. And then here's RUIXU tools. Looks like that's what I want. I need to extract that one as well. RUIXU tools. Then I have to click to trust this application and run it anyways. I'm not sure there's a better way of doing this, but yeah. I'm just gonna go ahead and try this side. 485. Let's plug in the communication cable. Okay, first I'm gonna go ahead and turn on my batteries. The manual says I should turn the master battery on first, wait 5 seconds, and then go ahead and turn the other batteries on. I'll just wait 5 seconds between each battery. Okay, I'm just gonna go ahead and select port COM3, that's the only one available. This has to be on Windows. Okay, so, well, cool. It's sensing that I have 3 batteries connected. That's awesome. Okay, great. So I'm just going to select battery number 0. So I think this is my master battery. Looks like it's 53 volts, 93% state of charge. I've cycled this battery 13 times. I have been messing around with these batteries a little bit. And look at this. It shows the cell voltage of each of the 16 cells. So if I have a bad cell, I can see that. This is measured in millivolts. Oh, cool. I can inspect each battery individually really fast from this. This is really nice. I don't have to break down each battery. If I've got a stack of maybe 24 of these batteries, I can just hook this up, and it looks like it goes all the way to, I could have 50 batteries right in a row according to this software, and I can measure each battery. So this is pretty nice. Okay, state of health. So I can come back maybe in a year and I can check the state of health. Hopefully that is correct. Looks like we have temperature, pack information. Let's check out these other tabs. Firmware. So it looks like if I need a firmware update, I get the firmware from support, and then I can browse and open the firmware file. But I think I need to do that with each battery individually. Okay, let's go ahead and hook these batteries up to the inverter and balance these batteries out. So these are both at 95%, and this one's right around 50%. I didn't think they were going to be this imbalanced when I connected them, but they're slowly balancing out. The voltage is so close though with these lithium batteries that it's going to take a really long time for them to self-balance out. So if I just look at this, I'm getting just under an amp. flowing into this battery. So it's going to take them a long time to balance out. But when I plug them into my inverter, I'm going to charge them up. These two batteries will take a charge for just a little bit, then they'll be 100%. While they're 100%, this one's going to be charging to 100%. So once I do this initial charge to balance everything out, I should be good to go after that. So I think I'm just going to run these conductors right through here so I can pop out this, and then I'll have a grommet here to protect me. So I think I'm just going to take this out all the way. So I think this is all powder coated. This is a pretty smooth lip here. So I'm just going to slide it in here rather than ruining this. So now I just have to hook the inverter cables up to the respective bus bars here. Now in theory, if I connect positive and negative right here, I should be drawing more from this battery versus this battery. The better option would be to connect this here and this one down here, so it would have more of a diagonal configuration and have more of an even draw on the battery. However, this cable is a little bit too short for that. So I'm just going to connect it right here. So this bus bar is so thick, there's probably hardly any resistance between here and here. So I think if I connect it right here, it will still draw evenly between all the batteries. So let's just connect it, and at the end of the video when we're hooked up, we'll test that and we'll make sure it's drawing evenly between all of the batteries. So I bought this cable from Signature Solar. It comes in a 6-foot length and it's 2/0. Now, one of the benefits of ordering from Current Connected is they can make you a custom cable. You don't have to do any of your own crimping. They have a professional crimper, and they can make you any size cable that you want, from my understanding. Okay, so the inverter we're going to hook into is the EG4 6000 XP from Lux Power. Now I'm going to want to make sure that these conductors going to my batteries are protected. So normally I'd get a T-class fuse, or on Signature Solar or Current Connected's website, they have DC rated breakers that you can buy for the respective conductors, size conductors that you have. But the nice thing about the 6000 XP is it has a built-in circuit breaker, so I don't need to add any more circuit breakers here. Now this one is 200 amps, so I need to make sure that the conductors that I'm using can support at least 200 amps so they don't melt. So I found this wire chart online that I just use, and it looks like this is 2/0 wire, so it can support 200 amps. So if I have more than 200 amps going through this wire, my breaker should flip, and so I should be safe there. So this is my main house electrical panel that this inverter was connected to. I temporarily disconnected it, and I just have these two lines, L1 and L2, which are going to be my loads for this test. But if you want to see how I hook this up and how this is running my entire house, I'll put a link maybe at the end of this video or at the top of this video here. But this system has worked really well so far. Let's talk a little bit about grounding your batteries in your cabinet. So the batteries come with these grounding terminals. Now, depending on your jurisdiction in your specific area, some areas might require you to ground each battery to earth ground. Some areas might not. But I could connect these terminals to each battery, and then in turn to the frame, even to the door, there's grounding threads I can hook into. And then I could connect that to a grounding rod if I was worried about lightning. This is inside, so I'm not really worried about that. If I should connect this to the ground and the frame of my inverter, and they kind of discourage that because sometimes if you have a weird situation where there's current coming across the ground, which really shouldn't happen, but if that was, suddenly your 120 volt AC is connected to the frame of your batteries, and that could lead to some really odd scenarios. So for me personally, I'm not going to hook this up. So let me know in the comments your opinion on grounding the batteries and the cabinets. Okay, I think we're good to turn it on. So this whole unit is off right now, except this DC breaker is on. So when I turn on this first battery, it should run the pre-charge resistor circuit, which will slowly feed power in here, so it won't damage any capacitors in this unit. And now I'm going to turn on each battery after waiting 5 seconds. I'm going to go ahead and turn on the inverter now. Now it's showing the battery at 79%. Now that is an average of all of the batteries. So I do have grid power from my main house panel feeding in here. So I'm just going to turn on the grid power and we're just going to charge these batteries. I'll just set it in the app to charge really slow to get everything balanced out. Okay, the battery is fully topped off. Each battery should be 100% now. So I'm just going to disconnect the grid. So this is just running straight off the batteries. And I've connected my 2 hair dryers here to L1 and L2. All right, so both those hair dryers running are pulling about 3,000 watts, which is about 0.2 C discharge rate between all of the batteries. So right now there's 62 amps coming out of the main connector. The top battery is 20 amps right now. 22.7 amps and 19 amps. So this is going to vary just a little bit. So let's drain it really low and see how it does. One of my hair dryers just died. Going through those hair dryers like crazy. It looks like our master battery is at 27% state of charge. Second battery is 24% state of charge. Third battery is 28% state of charge. So even though I'm hooking on to the top bus bar, which is closest to this battery, the batteries are, yeah, they're pretty darn close. Okay, so it just finished discharging all the way. It got down to 4%. I plugged my computer in here and it looks like each battery is at exactly 4%. Now I did have one issue when I was testing things about a month ago. I was testing a single battery and I couldn't get it to discharge. I think it was below like 20%. And I was asking support and they ended up doing a firmware update. And then I could get that down to 10%. And when I added more batteries in here, I could get it down to 4%. If I added 6 batteries, I could probably discharge it down to maybe 2%. So that's good enough for me there. The communication protocol works really good with this inverter. Now in the future, what I'm going to have is if my battery ever gets to 15% at night, I'll have the grid kick in and start charging it maybe just up to 20% and then shut off because the sun might just be coming out to charge my batteries. Now I've tested this functionality and it works great. Current Connected is selling these batteries. Now before they start selling batteries and storing them in their warehouse and providing support for them, I imagine they do a whole bunch of testing because they need to support connecting this battery to a variety of different inverters. If you live in other parts of the world, they do have distributors for this battery also. But I like the size of the battery. I like that it's UL 1973 certified. The cabinet is awesome. I think I'm probably going to get 3 more batteries to have a full cabinet. But I'm going to run this for 3 months with just 3 batteries and we'll see how much it can save on my power bill. If you want to see the full build of this, I'll put a link to the end at the end of this video to my full build. They mentioned that the cells in these batteries are the same cells in the Life Power 4 batteries as well as the SOK batteries, so really good cells. Another thing, they have a 10-year warranty. That warranty is only valid if you're using the closed loop communication. The cost of this battery right now is right around $1,200, and I think it's only like $50 extra to get the self-heating batteries. I can't find any other budget server rack batteries that have that self-heating option. So they do support, they do have a Facebook group that has over 300 members that you can ask questions to, and their support team chimes in and answers questions as well, and they do have a WhatsApp group. Thanks a lot for watching. We'll catch you guys next time. Let me know what you think of this in the comments. We'll talk to you later. Bye.